Okay guys, so this is the worksheet that we'd normally hand out in class, or I'd get you to draw it as a table very quickly in your books. But invariably I always have to walk classes through an example of every line. One, I'll do the top line for you, the phone charger. Everything on this PowerPoint is based on real numbers, so these aren't made up, these are taken off real devices. So I'll start with a phone charger up the top, and let me just grab myself a pen. Okay, so straight away I'm being asked what power is, so this has been left blank, so I need to, and you'll notice at the top of bar I have written in all the equations for you, but you'll have them on your revision sheet anyway. So if you need to solve this, power equals current times voltage. Well, we've got our current here, okay, it's in the column next to us, so that's 2.1. And the amount of voltage, well, it's a 5-volt system. Okay, so it says 5 volts for us. Now, everyone always asks, well, does it matter if it's DC or AC? Oh, this one's been left blank. That would be DC anyway. No, doesn't matter at all. Just use that number. So 2.1 times 5, which should be 10.5. Don't forget the unit, watts. Okay, that's the first column. There's only two others that you need to fill in there. You'll notice that this might be a slightly different equation, but I'll let you have a go at that when you get down to it. But let's do the rest of the top line. So we need to find resistance. So we haven't covered in any great detail resistance yet, but here is the equation that we're going to spend quite a bit of time on. Voltage equals current times resistance. So V equals I. Do you know what? I'm going to do this over to the side. V equals I times R. Then I'm going to rearrange it. I want to get rid of this I want to leave the R on its own, so I'm going to divide it, they multiply together, so I'm going to divide it by it, which is the opposite. By the other side also by I. My two I's cancel each other out, so I'm left with R equals V over I. So I'll bring that back over here. Okay, so I'm helping you out here. So resistance equals voltage over current, and so we've got 5 volts, and it's over 2.1 amps. Don't need to write the units in, so that's my fault. And that would be 5, get my calculator out. 5 divided by 2.1 will be, now if your calculator's like mine, it will come up with a fraction then. Don't use fractions in electricity. We want to use, let's say 2 decimal points unless we're told otherwise. So this would be 2.38. 2.38, and it's ohms. Okay, now on the previous slide we talked about, the last of the presentations, we talked about fuses. So if you haven't watched the video on fuses yet, you need to go back and finish that off. In this instance we've got 2.1 amps, and that means that we have a choice of a 1, 3 or 13 amp fuse. Well, a 1 would be too small. If we put a 1 in there, it would blow because we're already at 2.1. So I reckon our next best option is a 3 amp fuse. Now, if you're wondering why you don't find fuses in most of your phone chargers, if you have a look, you probably won't find one, because inside that big block that's attached to the wall before the cable comes out to your phone, there'll be thermally resetting fuses in there. So if your phone ever draws too much power, it'll just shut off. It'll stop sending it power until it cools down, and then when it's ready, it will start sending power again. And if you overload them, they just don't work. Okay, so the last one here is Q equals IT, so how much our coulombs, and we've been given the time, so we've been told if T equals 60. So again, physics problem, write down the equation, current times time, don't forget it's a little t, and so it would be 2.1 times 60, which equals 2.1 times 60, 126 according to my calculator. 126 coulombs. Okay, So that's the top line done, and obviously you've got that as a worked example to work your way all the way through to the bottom. I've left the microwave as a slightly tougher one. See how you get on with it. Stretch and challenge: if all the devices were connected to one circuit in your house, what would the total power and current flowing through that circuit, and what would the consequences be? Well, we talked about these earlier in the slides. There's a little hint because they might turn up in the weekly quiz, MCBs. You'll need to know what that term means for the quiz. There you go, there's a subtle hint. But otherwise, you can now, once you finish that sheet off, you can move on to the quiz. Good luck. Let me know if there's any problems.